My name is Sandra Magalhaes, and I'm a PhD candidate in epidemiology. My research focuses on the link between the sun and the risk of multiple sclerosis, which I'll call MS throughout this talk. All right, so in MS, the immune system is thought to attack the fat cells that surround the neurons in the central nervous system. So the fat cells are these yellow parts in this picture. And they're really important because they allow this electrical signal to pass through the nervous system extremely quickly because the signal literally jumps over these cells. So when the immune system attacks these cells, you get these MS lesions, which are the bright white spots in the MRI and spinal cord MRI images of a person with MS. And because of this destruction, the signal can no longer jump over these cells, and this significantly slows this signal, which results in both cognitive and physical disabilities, which is depicted here in a commonly used rating scale in MS as the EDSS, and it ranges from normal neurological function to bedridden and unable to communicate. So this figure gives you a sense of how many people had MS in different countries worldwide. And although you can't appreciate it from this figure, but Canada actually has the highest rates of MS globally. So high that the MS Society of Canada has actually coined it Canada's disease. So I study the sun and how the sun relates to disease. And so the sun emits ultraviolet radiation, or UV. And so UV plays important roles in many different processes in our bodies, including interactions with the immune system, which is really interesting for MS given the immune system's involvement. So how much sun or UV actually reaches you is dependent on many factors, and some of which are illustrated here in this figure. So some examples include cloud cover. Over 90% of UV can penetrate cloud cover, as well as 60% of UV that we receive between 10 and 2 p.m. As well, shade reduces our UV, but only by about 50%. So when we study sun, we need to consider all these different factors, though how we actually measure these things in real life in people is key to understanding the validity of our study results. So my overarching research question is sun exposure during childhood associated with the risk of adult onset MS? So I focused here on childhood because there's evidence from migration studies that actually suggests the age at which you migrate influences your risk of getting MS. So if you migrate before the age of 15, if you migrate before the age of 15, you obtain the risk in the country that you move to. But if you move after the age of 15, you retain the risk of the country you moved from. So this places childhood as a potential period during which MS risk is acquired. All right, so how can we answer this question? So I'm fortunate enough to have access to a very large data set from a study that my supervisor and her colleagues in Europe designed to better understand the risk factors for MS. And so the study was conducted in 5 countries with different distributions of MS risk, as well as different sun exposure profiles. And for this presentation, I've only focused on the results from Canada for the sake of time. So study participants completed a questionnaire that asked them about different and relevant exposures over their lifetime, including the amount of sun they were exposed to as children. So the bottom half of this figure gives you a sense of what we do with the information. So everyone over here is everyone who was enrolled in our study. We then separate them into MS cases and non-cases. We count the number of people who were exposed and not exposed to the factor of interest. Then we put these numbers into this infamous black box of fancy statistics, which gives us a numerical result, which we then must interpret in the context of our research question. So study participants reported how often they spent outside at different age periods, and I focused on the first 15 years. So if they answered quite often or virtually all the time, they were classified as being exposed to high levels of sun, and these people were compared to those who reported lower levels of sun exposure. So the graph gives you a sense of the results where I tested if people who reported high levels of sun exposure for a longer period of time had a lower risk of MS. And the evidence supports my hypothesis, as people who had reported high sun exposure for 15 years during childhood had the lowest risk of MS, whereas those who only reported high sun exposure for 5 years weren't as protected from MS as these 15-year people. So just to finish off, my conclusions are that individuals who spend less time in the sun during childhood are at higher risk of being diagnosed with MS. And in Canada, we already have a low amount of ambient sunlight year-round, so my research might help explain why MS is more common